Hello everyone, myself Ramya and I belongs to physics department from Alien Institute of Engineering and Technology. So in this session, I want to share you some information regarding a topic in physics. So the topic I want to discuss with you is about optoelectronics. So in this session, I'll be giving you the information about these optoelectronics, like what are these optoelectronics and how are these optoelectronics useful for us, and where can we find these optoelectronics and why should we prefer these optoelectronics. So let me start with what are optoelectronics. In the naming itself, it was like optoelectronics means it was like a combination of light and electronics. It is a combination of light and electronics. So in a simple way I can say that optoelectronics is a branch of technology. It is a branch of technology with a combined use of light and electronics. It's very simple. Optoelectronics is a branch of technology with a combined use of light and electronics. So there will be like optoelectronic devices present. So these particular optoelectronic devices, they are useful in manufacturing of hardware devices. So these particular hardware devices, they convert electrical energy into light energy and light energy into electrical energy. So I think I was clear with this question. What are optoelectronics in the sense? Optoelectronics, they are like a branch of technology with a combined use of light and electronics. And there will be also optoelectronic devices. These particular devices, they are helpful in manufacturing of hardware devices which converts electrical energy into light energy and light energy into electrical energy. So if you see this picture, you can find out these optoelectronic devices. And yes, let us go to next question. How are these optoelectronics useful for us? I can say that optoelectronic devices, these particular optoelectronic devices, they are playing a key role in technology field. That means day by day, the fastness of the technology is being increased. So definitely the backbone of that fastness, backbone of the technology, which is increasing day by day, will be definitely optoelectronic devices. Why? Because these particular optoelectronic devices, they are being involved in sourcing, they are being involved in detecting, and also they are also being involved in controlling of the light. So sourcing. So sourcing in the sense, if we are finding out something, we are finding out where something can be obtained. So in this picture, if you can see, we are finding out something which can be obtained and detecting. So detecting in the sense, it is like a process of identifying. So generally, we will be using some hardware devices in this sourcing and also in this detecting. So that particular hardware, that particular hardware devices, they are being prepared by using these optoelectronic devices. Why? Because here already we have studied these particular optoelectronic devices. They are useful in manufacturing of hardware devices. So yes. Next, where can we find this optoelectronics? So these particular optoelectronics, they are definitely, we can observe in automatic access control systems. So these all automatic access control systems, whatever they are present, they are being manufactured by using these optoelectronic devices. And these medical equipments. So these particular medical equipments, they are also being prepared by using these optoelectronic devices. And like military, in military there will be like some hardware devices. So that particular hardware devices, they are being prepared by using these optoelectronic devices. And also like telecommunication. So telecommunication in the sense, it involves like cables, it involves like telegraph, telephones. So these particular hardware devices, they are being prepared by using these, they are being manufactured by using these optoelectronic devices. So Um, so where can we find these optoelectronics means? Simply we can say that we can find these optoelectronic devices in military purpose and in telecommunications, in automatic access control systems, and also in medical equipment. So why? Why should we prefer these optoelectronics? So why not? So these particular optoelectronics, they are playing a major role in each and everything, like militaries, like access control systems, like medical equipment. So for example, if we take this telecommunication, so as we are using these optoelectronic devices, these are being prepared, these are being manufactured by optoelectronic devices. Definitely they'll be having like high bandwidth, and low consumption of the power can be observed, and also their cost will be like effective. So as we have these benefits, definitely we can choose these optoelectronic devices. So yes, these are the things I just want to clear you about this optoelectronics, and I'm just continuing this optoelectronics topic, applications. So I just want to I just want to explain you where these optoelectronic devices are applicable. That means they are just applicable in LEDs and like solar cells, like photodiodes, and like optical fibers. So I just want to continue this particular topic by explaining about LED. So I have just said that LED is being manufactured, is being prepared by using optical fibers. I mean, sorry, not optical fibers, optoelectronic devices. So LED. LED is nothing but light emitting diode. So light emitting. So emitting in the sense it is like producing. It is like sending. It is giving. So diode. So diode in the sense it is like the current which flows in a certain direction, in one particular direction. Uh, is nothing but a diode which which enables the current to flow in one particular direction. And this particular LED, it works on the principle of electroluminescence. So what is electroluminescence? Electroluminescence is nothing but a conversion of electrical energy into light energy. So simply, if electrical energy is being converted into light energy, then we can say then we can say it as electroluminescence. I have already okay. Let me go to this topic. LED, as I have said you, this particular LED, it is being working on the principle of electroluminescence. Now I'll say how it is going to work. So before going to its working, we have to differentiate two things. One is like a PN junction diode, and one is like LED diode. So for seeing these two diodes are like equal, but there was one small difference between this picture belongs to PN junction diode, and this particular picture belongs to LED diode. As they for seeing these both are like same, but there was one small difference, that is nothing but this particular arrows. So this particular arrows represents that light is being emitted. Why not in PN junction diode? You may get doubt. Why not in PN junction diode? Why only in LED diode means? I'll be just explaining you that point also. Uh, so uh, Let us go to its working. LED diode, it works. As it works on the principle of electroluminescence. It works on the basis of forward bias PN junction diode. So what is forward bias? So you already know that there will be like forward bias, and also there will be like reverse bias. So forward bias is nothing but P type. This particular P type is connected to positive terminal, and N type is connected to negative terminal. But coming to reverse bias, P type is connected to negative terminal, and N type is connected to positive terminal. But my LED diode, it works, that means it only works in a forward bias condition. So what is the process? We already know that suppose there was like LED bulb, the light is glowing, okay, but let us we may have doubt how what is the process involved inside it, how we are getting that light, how the light is glowing, what is the process involved inside it. So that is the thing I'm explaining now. Yes. So this particular diagram represents LED diode. So my particular LED diode, it has like a P type and N types, and in middle there was like a deflection region, and there are like positive terminals and negative terminals. To this particular LED diode, I was connecting a voltage, and I was just producing an electricity. As I'm producing an electricity, holes, these particular things, which are present in P type, that represents holes. I'm sorry. P-type represents holes and N-type represents electrons. So whenever my light is on, or whenever I'm sending an electricity, holes from my P side and electrons from my N side, these both, they'll be coming to this particular region. Means they'll be starting to come to this particular region. So this particular region is nothing but a depletion layer. So as soon as my holes from the p side and my electrons from the n side, they are recombining with each other, means they are combining with each other, they release the energy in the form of a light. So in this way, I'll be getting the light outside. My light will be emitted. So once again, I'm just repeating it. There will be holes in the p side and there will be electrons in the n side. So if I'm producing an electricity, holes from my p side and the electrons from my n side, they'll be gathering in this particular depletion region, which is very thin. Why I'm saying thin, in the sense, in reverse bias depletion region will be thick, in the forward bias depletion region will be thin. So my one positive and one negative, if it is being recombined with each other, they definitely release the energy in the form of a light. So that particular light is nothing but my emitted light. In that way, we are going to get the light. But one more thing I want to say you, if the same thing, suppose if I'm not taking LED diode, I'm just taking normal PN junction diode. Whether I'm getting light here, no, right? Why I'm not getting light here, in the sense, the same process will be happening. I'm just producing an electricity, but it is not LED diode, it is just a PN junction diode. So I'm just producing an electricity, holes from my P side and electrons from my N side, they are recombining with each other and they release the energy in the form of a heat. So please remember this point, LED diode, inside the LED diode, when holes and electrons recombine with each other, they release the energy in the form of a light. But in normal PN junction diodes, the holes from the P side and the electrons from the N side, when they are combining in this particular depletion region, they release the energy in the form of a heat. Why so? Why the difference in this sense? Why the difference means, my normal PN junctions, PN diodes, they are prepared by silicon and germanium materials. But my LED diode, it was prepared by gallium arsenide and gallium phosphate. So this is the thing why we are getting heat and why we are getting the light. So for easy understanding, for to make you clear, let me say, electron which are present in the conduction band, they just, whenever they are moving through the valence band, they emit the energy. That means they produce the energy in the form of a light, only for the LED purpose. But when electrons, they are moving from the conduction band to valence band, they emit the energy in the form of a heat in normal PN junction time. So in this way, we are getting the light. So we have come through how LED bulbs, inside the LED bulb, how that light is glowing. So what is the reason behind it? We just came to know. So yes, most of the people, they prefer LED bulbs. So what might be the reason? Means definitely it is like more energy efficient. That means minimum energy will be like wasted, and more efficient, more energy efficient, in the sense it is like a maximum achievement with minimum waste. So like it has a longer lifespan. So definitely whenever we are purchasing any item, definitely we will go through the time period. So these particular LED bulbs, they are like longer lifespan, and also they are like small in size, uh, and better controllability, in the sense, the brightness, whatever the brightness they are producing, it can be easily controlled. And yes, types of LEDs. There are like types of LEDs. Let me go through this RGB LED, red, green, and blue LED. So these particular LEDs, they are useful for decoration purpose, and alphanumeric LEDs. So alpha in the sense ABCD, numerical in the sense 1, 2, 3. So these particular LEDs, they represents alphabets and numbers. And high power LEDs in the sense they just produce the light in this way, flashlights. And yes, uses. Where can we use this LED bulbs? So day by day we are observing, we are moving in between. We are moving through many items like phones, televisions, and everything. But we don't know the light behind it, the reason of the light behind it. So LED, there are these particular LEDs are used in the sense they'll be useful in the smartphones displays, and in camera flashlights, and in televisions, and in street lights. We'll be using these LEDs, and in signals we'll be using these LEDs, and like in bulbs, which will be useful in homes and offices. In houses and offices, we will be using the lights or bulbs, right? So we can use this particular LEDs in our house and offices also. So this is some information regarding LEDs. So I just gave you some information about what is LED, and on what principle it is working, and how it is working, and advantages, means why most of the people are preferring LEDs, and like types of LEDs, and also like uses where we will be using this particular LEDs. So this is the thing I just want to share with you in this session, and I hope that you have been understand what I have said to you, and thank you.